Welcome to Miss Taylor's class notes. And before we get started with this one, I want to make sure that we understand a couple of concepts. So we are going to use our theorems from yesterday when lines are parallel. So we are only going to use our traditional theorems when we know that two lines are parallel. We are going to use what we taught today, our converses, to prove lines are parallel. And so we use the theorems when we know the lines are already parallel. We have to use the converse if we don't know the lines are parallel to prove that they are parallel. So if we remember back from last unit, converse means switch. So we're going to so what we've done is we've taken our corresponding angles theorem and we've switched our hypothesis and our conclusion. So now we know that if corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. If consecutive interior angles are supplementary, then the lines are parallel. So we're going to use this time our angle relationships 2 being congruent to 6 to prove that J and K are parallel. We're going to use that my alternate interior angles are congruent to prove that these two lines are parallel, so on and so forth. So it's still the same thing, it's just we've switched them. So we know the angles are congruent, and because we know the angles are congruent, then the lines are parallel. And then this last brand new theorem is that if it's transitive property, and it's transitive property of parallel lines. So if P is parallel to Q, A equals B, and Q is parallel to R, B equals C, then we can cut out the middleman, and A is parallel to C. And so that's all that means, is that if P is parallel to Q and Q is parallel to R, then we know that P is parallel to R. And that's all that means. It's just more transitive property. It just works with parallel lines. So now we're going to get into some proofs and talk about it. We're going to start with some baby proofs, some one-step proofs, and then we're going to get into some full-blown proofs. So we're trying to see if we have enough information to prove that M is parallel to N. So to prove that M is parallel to M, we must use the converse. So I have an angle that is congruent to another one. They are on opposite sides of the line, and they are outside of my parallel lines. So that's going to be the converse of alternate, I'm going to abbreviate, exterior angles. And so yes, M is parallel to N. Oh, went horribly wrong. So here I've got two angles that are congruent. They share a vertex and they're on opposite rays. And so these are vertical angles. And while, yes, we know that vertical angles are congruent, vertical angles is not enough information to prove parallel. Linear pairs and vertical angles cannot be used to prove that lines are parallel. It can only be those four converses. So let's look at this here. We're going to prove that AC is parallel to DF. So we're looking at these two lines here. So we need a transversal, or we need to look at a transversal. We've got to look at the green lines. We cannot look at the other direction. So yes, we know these two are corresponding, but those two prove that our two green lines are parallel. They do not prove that AC and DF are parallel. So there's a couple of different ways we can look at it. I know that 65 is corresponding with this angle right here, but I don't know yet that that's 65 degrees. I've got to have some way to prove that that is 65 degrees. So I know that 115 is a linear pair with this angle here, and I know that they equal 180 degrees. And because they equal 180 degrees, we're going to subtract 115, which gets us a 5. That becomes 6. And so we know that this is 65 degrees. And so once we've done that math and we've done it's a linear pair and we've proved that that angle is 65 and we know that these two are congruent, then yes, AC is parallel to DF because of our converse of corresponding angles. So if we look right here, we have two vertical angles. I have no way of knowing that this angle is also 62 degrees. We don't actually know that information. So no, I do not know if they're parallel because vertical angles cannot be used to prove lines are parallel. So the other types of questions you're going to see is find the value of x that makes them parallel. So that's where you've got to use your angle relationship. So we're trying to prove that P is parallel to Q. So I'm going to use this transversal right here. And so I know that these two angles are and should be, or are corresponding angles. I know that corresponding angles are congruent. So 2x plus 2 equals x plus 56. And once we set up our problem, we can solve it and find the value of x, and that value of x proves that the lines are parallel. So I'm going to ask you to do that one on your own and check with the completed notes. So now we want to prove that R is parallel to S. So if I'm going to prove that R is parallel to S, I'm going to use transversal Q. So these are consecutive, they're on the same side, and they're exterior, but I don't have a theorem for consecutive exterior. But I can use my vertical angles theorem to move both of these values inside because I know vertical angles are congruent no matter what. So now they become consecutive interior, and we know that consecutive interior, when we add the two angles together, equals 180 degrees. So once we set up our problem, we can solve for y, and that value will make R parallel to S. So go ahead and do that on your own and check with the completed class notes. Go away. So now let's talk about this one. I'm going to have you write a 2-column proof. Our given is already right here. We know that these two angles are corresponding angles. So we're going to use our corresponding angles theorem. And because they're corresponding, we're going to set 95 equal to 8x plus 55. And then I want you to complete this like it's an algebraic proof. So I want you to subtract your 55, divide by 8, and all of that. That's kind of a baby proof, just kind of introducing us to the concept. All right, so now we're getting into our full-time, full-blown proofs. So we have our statements, and then we have our reasons. So what we've been told is we have been told that angle 1 and angle 3 are supplementary. And that, I'm going to abbreviate supplementary, and that is our given. So we know angles that are supplementary add up to 180. Measure. And that is because of our definition of supplementary. All right, and that's all the information that the given tells me. So now I'm going to go back and I'm going to look at my diagram, and I'm going to see what, 1 and 2 are vertical angles. So I know that angle 1 is congruent to angle 2. Pencil, why'd you stop working? Because they are vertical angles. And so once I know that 1 is congruent to 2, I know that the measure of angle 1 is equal to the measure of angle 2. Because I'm going to have to substitute them into this right here, I need to make them look like that angle there. So this is our definition of congruence, or congruent angles. because if angles are congruent, they are also equal. So now I can substitute in, because I need to prove that M is parallel to N, and I've got these two angles here, which I know are going to be consecutive interior. So I know that consecutive interior equal 180, so I need that 2 plus 3 equals 180. So I've already got 1 and 3 equal 180. Ooh, and so now I can just simply substitute 2 in the spot of angle 1, because I know that 1 and 2 are equal. So the measure of angle 2 plus the measure of angle 3 equals 180 degrees because of substitution. And once I know that line M is parallel to line N, because we know that 2 plus 3 equals 180, so that's our converse of consecutive interior angles. And we are now done with our proof. All right, so let's look at one more. This is one of the ones that can be a little more complicated, but if we break it down step by step, piece by piece, we can find what we need and we can get there. So let's talk about what we need to prove first. Sometimes it helps to start with the end in mind. We need to prove that AB is parallel to CD, which means that this is going to be my transversal. And if it helps to draw these things out so that it's easier to see, do that. And if I know those are my transversals, because I have this angle marked and this angle marked, I know that they are going to be alternate interior. And if they're alternate interior, that means that 1 needs to be congruent to 4. So that's where we need to get, that's where we need to go. And so let's see how we can get there with the information we're given. So statement, reason. So I'm going to put both givens in the same spot. So angle 1 is congruent to 2, angle 3 is congruent to 4, and that's our given. Okay, none of them overlap, so I can't use transitive. There's not a lot of places I can go, so now let's look at our diagram. So in my diagram, I notice that 2 and 3 are going to be congruent because they are vertical angles. So angle 2 is congruent to angle 3, vertical angles. So I need to get to 1 is congruent to 4. So I need to substitute 1 is congruent to 2, 2 is congruent to 3. So I know that 1, I can cut out 2. And if I cut out 2, then I can say that angle 1 is congruent to angle 3 because of our transitive property. You could have also used substitution. They both work in this situation. So now I know that 1 is congruent to 3. I know that 3 is congruent to 4. So again, I can cut out my middleman, and angle 1 is congruent to angle 4. Again, using our transitive or our substitution properties. S-T-I-T, yeah. And so, ooh, looky there. I've already proved that 1 is congruent to 4. If I know that 1 is congruent to 4, then I know that AB is parallel to CD because our converse of alternate interior, I abbreviated both of these angles. And that is how we use proofs while proving lines are parallel.